Good morning, Pierre Marie.
Good morning, Salva.
Welcome to the Institute of Neuroscience. We are going to finalize all the events we have organized for the 20th anniversary. We are very happy to have you here again, because we know that you are a good friend of the Institute of Neuroscience in Alicante.
Always delighted to be here.
Okay, wonderful. So we have been listening your talk, and was a pleasure to understand most of the things you have presented us. And one of the most striking stuff is the question about adult neurogenesis. What is the state of the art at the present about?
Like always in science, when there is an hot topic, it's always a controversial topic, and which means only that is a scientific issue. The last papers came from a team in Madrid, definitely show that not only adult neurogenesis is true, but he also demonstrate why the other people who claim that there were no adult neurogenesis in the adult brain were wrong because of technical issues actually. So sometimes it's more easy to demonstrate that nothing is present than to demonstrate and bring proof of the observation of the mechanisms.
Wonderful. So, but the next question in relation with this is, what are the new neurons doing? So, what is the new thing that's happened when you have new neurons in a circuit?
I would say in our daily life, when there is no precise challenge, they are not very useful. But we have to consider these newborn neurons as a cognitive reservoir. We can help. They can help us. They can be a kind of a pool that will recruit when we are challenging difficulties, like for instance, how to discriminate things that can be very similar. Then they are very useful.
But this pool of new neurons, progenitors, has been disappeared, because we know that the neurodegenerative diseases are there. Why we have finally we end with a neurodegenerative disease?
Right, so that's a very important issue that a lot of people are working on it now, and trying to make a distinction between quiescent adult stem cells and proliferative adult stem cells. So the challenge nowadays is to really understand what, from the metabolic part of the system, these neuronal stem cells can turn on and divide again. So there are a lot of efforts to bring in this topic.
And the second part of your talk has dealt with the microbiota and the effect of the whole body in the brain, how our behavior can be contaminated or modified by the whole brain, the whole body,
Yes.
And mainly the microbiota. Can you just briefly tell us the main message about that?
Briefly, I would say that we have to develop this holistic vision where the brain is taking advantage not only of interaction from the external world, but internal states, and not only the blood enter into the brain, but blood bring metabolite, and most of the metabolites are coming from this microbiota that we have to consider as a chemistry company producing compounds that we are not able to do.
Okay. So, and in the relation with that, we have learned that important metabolites are provided by the microbiota, and so we need to have more. We can modify with the diet the mental state. That is true?
Yes, so this is very interesting to see this microbiota as an ecosystem which is going to depend on what we eat, what we do with our body. If I run, if I stay quiet, or if my immune system is reacting or not. And we know that the immune system is under control of the mind. So there is really an intrication between the body and mind, and who is the first? That's a more philosophical questions.
And the last question, you have written a new book that is called The Brain in the 21st for the new
Yes.
brain in the 21st century.
Yes.
Has the brain solution for the 21st century? The human being
That's a very
has a
interesting.
solution or not?
It's. I think there is no solution for individuals, but the solution is collective.
Wonderful. Thank you very much.
Thank you very much.